In this problem, we look at exponential distribution, which has a very close relationship with the Poisson distribution. Whereas the Poisson distribution is a discrete, or Poisson random variable is discrete, the exponential is its corollary continuous random variable. Cell Cells Incorporated, the cell phone retailer mentioned in problem 1, uses a large number of common batteries in one of its most popular lines of phones. After testing a large number of them, they found that the average time to failure is 1 over lambda, which is 7,800 hours. So here's why I say that these two distributions are related. If this is the Poisson distribution and we're saying between two failures it takes about 7,800 hours, then the inverse of that is essentially the failure rate. So if one failure in 78 hours, then how many in 1 hours? And of course that's 1 times 1 divided by 7,800. So 1 over 7,800 is our failure rate, which we can compute. Now that will be the parameter that goes into our exponential distribution. So now we want to we go like this. We have equals expondist, and our x is what is the probability that the component will fail within 1,000 hours. So it means it takes 1,000 hours or less. So our 1,000 is our x value, our lambda is 1 over 7,800, and I want to say true because we want the component will fail within 1,000. So that's 12% chance, or 0.12 probability. This is probability of fail within 1,000 hours. And then it asks, what about after 7,800 hours? What's the probability that it will last 7,800 hours, and then after 7,800 hours it will fail? So again, we use the expon distribution function, but now we want to subtract from 1 what we get. So well, actually I can write it like this. I'll just do expondist, and 7,800 is our number. Lambda is 1 over 7,800, and I do want it cumulative. But if you consider this is really, if this is the exponential distribution, and this is 7,800, then this calculation here just gave me this area to the left of the 7,800. So, but this is what we're looking for. This area is what we're looking for because it says after 7,800. So essentially I would have to take this and subtract it from 1 so that I know what the area is that I'm looking for, which is which is this area right here. Okay, so that's the answer. 38% chance that the batteries will fail after 7,800 hours. Okay, thank you.